Hey, everybody. Welcome to the PC Perspective Podcast. This is episode 244, being recorded on March 27th, 2013. I'm Ryan Schraub.
I'm Jeremy Hellstrom.
I'm Josh Walrath.
And I'm Alan Malventano.
You know, it's a little different when you're sitting in a room talking to yourself.
You know, for a minute there, I thought that you were on speed.
Because I was talking really fast?
Podcast. This is episode 244.
That's just a Skype going back to you. So I'm obviously out of town. I'm at the Game Developers Conference here in San Francisco. But that's not really what we're here to talk about. I haven't really seen any really big news yet. We'll talk about the one piece that we got about the preview of the Radeon HD 7990 as an official product. But let's get into some of our other stories first. It's been a graphics card heavy week. The first two stories I'm going to talk about very lightly and with not much detail, simply because we have a lot of other things to discuss. First up was the release of the AMD 7790, and I said all those numbers correctly this time, 7790. So this is a card that's between the 7770 and the 7850, but what's interesting about it is that it is a completely new ASIC. This is not built off of any previous Pitcairn or Cape Verde GPU. This is actually Bonaire, part of the Sea Islands family of GPUs. It has the same architecture, though. It's a new GPU, but it's not really fundamentally different in any significant way. It has a different shader, different stream processor count, but other than that, it's very similar to other designs. It fits in between those other two windows in terms of specifications, in terms of die size, in terms of processing power. It doesn't really cause any big influx of changes here. The only kind of feature change in it is actually with their implementation of PowerTune, which is PowerTune with Boost. Essentially, when they released Boost in the first instances, which is with the 7970 gigahertz edition and the 7950 with Boost, they were very kind of wishy-washy about what steps were between the base clock and this boost clock, and how often it's spent at the top one and how often it's spent at the not top clock. And the way that the power phases, not the power phases, the power steppings were kind of broken down was that the GPU, like in GPU-Z or anything like that, anything that reported the clock speed of the graphics card, it always reported the maximum speed. Anytime it wasn't at idle, it always reported the maximum speed, even if we knew that wasn't correct. The new version of PowerTune, which I think they're just calling PowerTune 2.0, is there's actually 8 individual states between idle and boost, which basically it allows the GPU to be more efficient in how it steps between different clock speeds. It doesn't have to go all the way to the top voltage, even if its clock speed can't go to that high. Now it's in there kind of bend correctly in terms of, this voltage correlates to this clock speed, this lower voltage correlates to this specifically one step down clock speed, and that kind of thing. But so it's interesting in terms of, you know what the clock speeds are going to be now. They have more states. It's going to be more efficient on the back end, but it's not any different really towards the end user experience of how things change. You're still going to be running at the boost clock almost 100% of the time. Very rare cases in any kind of games will that not be the case. And it kind of goes back to the fundamental difference in theory, or whatever you want to call it, between what AMD does with Boost and what NVIDIA does with Boost, because NVIDIA wants to get the most performance out of each GPU ASIC, even if that difference is a little bit different between each GTX 680, for example. With AMD, they were always very adamant that every 7970 gigahertz edition would perform the same, and every 7950 Boost would perform the same, given the exact same conditions. With the GTX 600 series of Kepler cards, that was not the case. With the 7790, it still is the case for AMD that every 7790 given the same base and boost clocks at the beginning, will perform the same in any system with any ambient temperature, with any anything like that. So they're not kind of changing their game and going into the world of truly dynamic and changing clocks based on the specific health of that chip or anything like that. 7790, excuse me, is performs between a 7770 and a 7850, but it's actually a little bit closer to a 7850 a lot of the times. We actually tested an overclocked model. Excuse me for a sec. That ran at 1075, so 1075 megahertz, but the reference clock is 1000 megahertz, or 1 gigahertz as we commonly refer to it in these parts. 6 gigahertz on the memory bus is also a change. It's an upgrade over what we've seen before, 6 gigabit per second on a 1 gig GDDR5 frame buffer. Pricing puts it, what is it, it's 159, I guess, something like that. So it was interesting. When this card first launched, it actually looked a lot better than it did just a few days later after the 650 Ti boost launched. But we'll talk about that in a minute. If we look at Battlefield 3, I know Ken just had a couple of graphs up there for us. You'll see that the 650 Ti is definitely the least impressive card in this setup, comparing the 650 Ti to the 7790 to the 7850. 7790 is definitely sits kind of almost exactly in between them there, and we're only really testing 1080p results in this case, just because it's definitely the target of this price range of cards. Crysis 3 looks the same. Far Cry 3 very similar. It's a good card. It addresses a gap in their product stack that they didn't have before, or that they didn't have filled before, and now it's there if people want it, and it's a really good budget, I guess I'll call it, mid-range card. It's not quite as power efficient as the GTX 650 Ti, but it's also performing better than the 650 Ti, so no drastic changes there. Looks like the MSRP on the Starfire model that I tested was 169. So also good news. It comes with a free copy of BioShock Infinite, which is a pretty big deal considering how well received that game has been over the last, I guess, couple of days since the game's release. 10 out of 10 I saw in some places, and 5 stars. Apparently those are good scores. I don't really know. But a good game to include, and if you were thinking about buying that, it's a $50 or $60 value that's hard to pass up. But let's move on to the next card, because I think it...
Are you sure? Sure, we don't want to talk about that some more? Isn't it pronounced Bonaire? And didn't Ken snicker at it when he found out?
I thought it was Bonaire, like the car.
Whatever. I like Bonaire, but...
I bet you do.
Yeah. Hey, one thing that's kind of interesting about that part is that, it's a brand new ASIC. It's a new chip. It's kind of interesting. It's a, 160 millimeter square? Mm-hmm. So it's still about 40 or 50 millimeters bigger than... what is that, Pitcairn? Or is that... Yeah, what's the lowest end?
Cape Verde is the lowest.
Cape Verde. And then, it's the Pitcairn is about 220, 240. Mm-hmm. So it's pretty significant savings in die. And if you think about it, this is an 85-watt TDP part, correct?
Yes. Yeah, it is.
Yeah, I mean, it requires one 6-pin and really barely even that. Now compare it to the product that we're just about ready to talk about. The 650 Ti Boost, what's the TDP on that puppy? 140.
Yeah.
And how much is the performance of that one over the 7790?
Well, I don't know. We haven't talked about it yet.
Dang it. But anyway, keep that in mind, because power is a big thing. I'm almost talking like Christopher Walken. Because power is a big thing, right?
Let's talk about that card, because I think it needs to be one story, because they came out so close together. Anyway, so the 650 Ti Boost is really not a 650 Ti at all. It is more or less a GTX 660 with a little bit pulled back from it. So it has a 192-bit memory bus, which the GTX 660 has, as opposed to the 128 of the 650 Ti, which makes a significant difference in terms of memory bandwidth. It does still have 768 CUDA cores, which is the same amount as the 650 Ti, but you're running at higher clocks, and as the name indicates, you're running at boost speeds of up to a typical clock of 1033 megahertz. So the memory bandwidth actually goes up from 86.4 gigabytes per second to 144 gigabytes per second if we compare the 650 Ti to the 650 Ti Boost, which is why I don't really think that comparison is as fair as it is to a 660 or Or to compare the 650 Ti boost to the 660. Still the same chip. It does have the higher TDP, as Josh mentioned. It has a 2 gigabyte frame buffer instead of a 1 gigabyte frame buffer. And it also introduces SLI support, which the original 650 Ti did not have. That's why this is basically a GTX 660 with one SMX unit turned off to become a slightly lower cost version of that same product. Otherwise, it's very much the same. Now, if you look at pricing of this, NVIDIA did a good job of aggressively pricing it. The MSRP is $169 for the reference models and for the non-overclocked models, which puts it directly against the 7790 OC that we talked about in the first article. That puts it within $15 of the Radeon HD 7850, which is 185, and the GTX 660 is 230. So a pretty sizable step up considering the price range. Now let's look at performance. Compare the 7790 and the Ti Boost, the 650 Ti Boost cards. And if we look at the Battlefield 3 page, for example, it's a little bit harder to read because I did want to put five different products on here so we could show that as complete a story as possible. And notice that the kind of hunter green, I'll call it, 650 Ti Boost result is right about the level, if not a little bit faster than the 7850. And then, a little bit behind the 660, as you would expect. But look where it is compared to the 7790. It's a pretty sizable jump up if going from the 7790 to the 650 Ti Boost, especially considering the prices are identical. Yes, the power consumption is better on the 7790, without a doubt, but both still only require one 6-pin power connector. So if your power supply can handle it, your power supply can probably handle it. But performance, you look at Crysis 3, it's going to be at or above the 7850 range. So really the 650 Ti Boost kind of competes directly with the 7850, and the majority of the time is able to beat it in terms of your average frame rates and all that kind of stuff. So two things that I took away from this is that the sucker's bet is now the standard 650 Ti was never a good card. I never liked it. I always thought its performance was way lower for the price that they were charging for it. And the 650 Ti Boost now is almost as good as a 660, but like $60 less. So it makes it a very, very compelling option for that sub $200 graphics card buyer. And it's $15 less than the 7850, but I mean those prices can change that little of amount almost hourly, it seems. And I came away actually really liking the Ti Boost. It does use a lot more power. It uses more power than the 7850 does by about 10 or 12 watts. And it uses almost the same power as the GTX 660, which you would kind of expect as well. So now that you know all that information, Josh, what do you think?
I think it's great to be a consumer at the sub $200 level.
That's it. That's all you got. That's all you know.
No, that's not all I got. I think it's fascinating to watch the play between these two. I think we're going to see a pretty drastic drop in $15 on the 7790 now that it has competition in that area. But yeah, if you kind of look before with the 650 Ti and then the 660s and then the 7770 and the 7850, there's a massive performance gap. So it's great that both of them have gone in and plugged this gap with two pretty good products. I think AMD again needs to come down a little bit more. I mean, initially they had a pretty good product for the price range, but then NVIDIA sort of spoiled their little party. But we'll see those prices go down, and I think the 7790 is a less expensive product to actually produce. So their margins are not under the kind of pressure that I think NVIDIA will probably see with the 650 Ti Boost. Again, there's 85 watt to 140 watt TDP difference. That's pretty significant. You would expect that the 7790 would be able to overclock a little bit better. It's got a little bit more headroom than potentially the 650 Ti Boost. And again, it's a slightly revised GCN architecture. It's a little bit more optimized, so faster per clock than previous products. But still, I mean, it's neat to have some actual competition in really what is kind of the sweet spot for the budget enthusiast. It's not too slow, not too fast, not too expensive, not too hot. So these are both really, really neat products to see. Just kind of wish that NVIDIA, again, if we look back at the 7970 launch and then when the GTX 680 came out, I mean, the thing that they really pushed was, hey, we're about as fast, if not a little faster, at release, but we're using a whole lot less power. And now we're kind of at the point where the architecture didn't quite scale to this lower node in the marketplace in terms of wattage and performance. And now we're seeing AMD kind of take a small advantage there. But it's nice to have competition. It's nice that one is not the overlord over the other. Even though as we get into frame rating, we'll have a lot of interesting things to discuss.
Yeah, before we do that, though, let's do a quick overview of your interview with ARM. Now the name is escaping me here. We interviewed ARM Mali
Nizar Rumdan.
Yeah.
Yeah.
And so this is kind of something we're hoping to do a little bit more of in the future going forward. He is the head of the Mali ecosystem at ARM, and we have the full interview posted up on the website. But I wanted to give us a quick overview of what you learned from the talk and why it might interest.
Absolutely. He went into a little bit more technical talk about the architecture. It's actually a unified shader piece. It's a deferred render, tile-based renderer. Much like Imagination Technologies and Power VR and the stuff that we've kind of expected to see from them. It's very power efficient. It's OpenGL ES 3.0 compliant. So that means, remember when NVIDIA was talking about their latest Tegra 4 and how it wasn't quite OpenGL ES 3.0 compliant because they were rendering in FP20. Well, this is obviously a full FP32 part. Unified shaders again. It's because it's tile-based renderer. It doesn't require as much bandwidth as the standard immediate mode renderers that NVIDIA and AMD really seem to like for a lot of really good reasons. It's the Mali architecture has been around for quite some time. It's very popular in a lot of the lower end tablets and cell phones. It again is a licensable IP that is very similar in ways to the Imagination Technology. The guys license out the designs integrated into their ARM designs, and you've got an ARM Cortex A9 comprised with a Mali T5 something. I can't remember the exact model names, but now they've introduced the T604 and the T600 series, and again this is the latest generation. They're up to DirectX 11 compatible, but the interesting thing is that they're not one of the authorized architectures for Windows RT. So you're not going to see these in Windows RT anytime soon until Microsoft kind of changes their mind. But they probably still can work in Windows Phone. Obviously, they work in the Android environment, and they utilize the OpenGL ES 3.0 functionality. Talked a lot about what they're planning to do, how they're trying to address the market, where they expect changes in the mobile gaming, and what they're doing to kind of make their product a lot more palatable and interesting to not only companies who are licensing, but end users who will eventually just be looking at the pretty pixels being displayed on their 1080p device that's 5 inches long.
Oh, I'm sorry. 5 inches long? Whoa, easy now.
Yeah, I know. Well, it's average anymore. So, did you watch some of that interview?
I watched a little bit of it, but I was on vacation when we got it up there and posted. So, and then I immediately came back and went to GDC. So I have not watched all of it though. It seemed interesting. Like I really like to get these types of I want to say competitors, but these types of graphical options out there and start to really dive into what differentiates this from Tegra 4, from what Qualcomm uses, from what Samsung uses, and I think that's almost a more interesting story than on what you get on desktop PCs these days. It's on smaller devices, but I think it can be more interesting.
Yeah, certainly. I guess that it is not Windows 7, Windows Phone yet. I think Qualcomm and the Adreno are the official devices for that one. But anyway, they're still really pushing with the Android. They're part of Kronos, which is the OpenGL over group that decides what's going to be in the specification. They're OpenCL compliant. And again, they can support up to DirectX 11, and they have a pretty decent driver group working with them. But again, we're only really seeing right now the OpenGL ES with the Android marketplace that this is predominantly put in. Ken, have you had any experience with any of the ARM Mali with some of the lower end tablets?
Nope.
Nope. Oh,
Nope.
Well, I thought he would be. But stuff like Archon, who's the guys that we talked about? Rock what? Last week, the Chinese ARM licensee. Anyway, there you have it. Go watch the interview. It's kind of interesting. He's a little hard to hear. Next time we do it, we're going to have a little bit better webcam on their end, and certainly headphone and microphone, so that we can hear each other
Always
a little bit better.
What a novel idea.
I know.
What a novel idea. Okay, so here's what we're going to do now. Obviously, we need to talk about the frame rating stuff. I'm thinking maybe we won't talk about it as much as we maybe had thought, but we'll see how that goes. I think maybe what we'll do here now, Ken, is we'll stop for our ad break, if that's cool with you. And then we'll go ahead and jump into frame rating for a little bit, and then we'll kind of go through some of these news items and see which ones are important and prominent and need to be discussed on an incredibly busy week. So let's say hello to this week's podcast sponsor.
The all-new Z77 M-Power mainboard from MSI is poised to change the overclocking game. Every Z77 M-Power board will have a factory 24-hour military-class burn-in test completed before shipping. Additionally, performance-optimized features such as Go-To BIOS, Multi-BIOS 2, V-checkpoints, Bluetooth 3.0, and onboard Wi-Fi allow users convenience and total system control over their overclocking and gaming experience. This is the new endurance champion, Z77 M-Power from MSI.
Boom. All right. Let's
the
figure out.
all-new.
What's that?
6 months ago. The all-new M-Power from
It's
6 months
still
ago.
all new. Do you know of any newer motherboards than the Z77 series of chipsets?
Officially?
Yes, I guess. Yes. Okay, so frame rating is the thing I've been working on for a while, and we finally released it. I got to tell you, on the walk back from the last meeting I was at to the hotel to do the show, I was trying to figure out what I wanted to talk about with frame rating, how I wanted to address it, because I feel like it's something that we've talked about forever and ever and ever on the podcast.
Are you just going to vomit a bunch of graphs onto the screen, onto the webcam?
Yeah,
Watch the
see,
slideshow. We're just going to sit quiet.
That was 2 days ago, right?
Right. Yeah, no, it's a different kind now. But see, that's the thing is I don't want to kind of just throw a bunch of graphs on the screen and all that kind of stuff. I would much rather, I don't know, like try to dive into the theory behind it. So,
Well, can you tell us a little bit, first of all, frame this
Just
in
give
the
us the
history
results. How
of
about
what you have done with this, how you've worked with NVIDIA to get to the
Okay.
point we are now? Because a lot of people don't know. Heck, I don't even know all the back story.
So about a year ago, it's been a little bit more than a year now. NVIDIA, not NVIDIA, we'll just say a particular Tom who comes out to visit us a lot, started talking about frame times and some of these inconsistencies that they had seen with fraps and versus some other things that they had looked at. So we started a discussion about how can we actually test game performance in a more direct way, in a more user perception format. And the idea came up as like, okay, well, if we could use a high-speed camera and or a capture system to capture the output directly from the card, that we could somehow begin this measurement process of actually measuring the frames that you saw on the screen. So we started looking into researching, okay, what kind of, high-speed cameras have all kinds of other issues, because if you're going to record video, they have limitations. Their resolutions are sometimes low unless you're going to buy the really, really, really expensive high-end stuff. And you have to frame it correctly, and there's all kinds of things. Direct capture would be cleaner if we could figure out how to do it, but the issue was being able to capture more than 1080p at 30, which tends to be, kind of the maximum that you would normally find. So Ken and I did a lot of research. We found this card called the DataPath Vision DVI DL from a company called DataPath in the UK that they had never sold one in the U.S. before. We were actually we bought the first one in the United States. We got it in. We started the testing process. We started working with that team in terms of getting the drivers to a point where you could actually work with this stuff. Right? We couldn't figure out how to actually capture 2560 by 1440 or 2560 by 1600 for quite a long time, and that was one of our limiting factors for a while. NVIDIA provided two key pieces of software for us. After my attempts to find a developer to do the overlay had failed twice, after wasting a considerable amount of my own money, which is awesome, they wrote it in like 3 weeks, because that's what they do, is that the overlay piece of software that takes a sequence of colors that is predetermined and puts a colored column on the left-hand side of each frame as it is being rendered from the game engine. And it applies it to the whole frame, and then for the next frame it applies the next color, and for the next frame it applies the next color. And it does that in succession. And then when those frames are actually displayed on your monitor, you'll get portions of those colors. You may get a whole screen of that color, or you may get 5 or 6 colors on that screen, depending on what your actual frame rate is. And so the idea was, by then post-processing that video, we can measure how long. We can measure the pixel height of each of those colored bars, thereby telling us how long that frame was displayed for, thereby giving us individual frame times as well as frame rates, and we can get a whole bunch of cool statistical data out of it. So they wrote this overlay software that basically, at the same point, Fraps is the most common piece of software used for performance testing today, where Fraps inputs its overlay, where EVGA inputs its overlay, where MSI's Afterburner inputs its overlay. This program inputs an overlay color on a specific location. And that's all it does. It doesn't record anything, it doesn't log anything, it's a dumb application, and that's all it does is it outputs colors. So now the capture hardware that we kind of found and have been perfecting over the time, right? Like NVIDIA could only capture 1920 by 1080 for a long time until we figure out how to capture 2560 by 1440, which turned out to be where all the interesting results are, or at least the most interesting results are. We take that into a completely separate system, outputs into that. We capture that, record it as a uncompressed high bit rate. And when I mean high bit rate, I mean like 400 megabytes per second, not megabits, megabytes per second. Record it, and then we can post-process that video. And that's the other piece of software that NVIDIA wrote. And it's also kind of what I would call a dumb application, in that it will read the video file, count the pixel height of each of those colored bars, and output that to an XLS file. It's a completely dumb application. It doesn't do any of the analysis. It simply looks at the first frame and says, oh, look, I found a green bar for this many pixel lines. I found a blue bar for this many. I found a white one for this many. I found an orange one from this many. Output it to a file. Okay, now it's up to you to figure out how to analyze that data, make sure all the colors are there where they're supposed to be in the right order, and that kind of stuff. And that's kind of how the process started. And we have posted 3 different previews of frame rating, which is what I'm calling it, frame rating, since January until today. And I think we've given a pretty good idea of kind of what the process is, what we look for, how we can determine things. And I guess maybe the 2 key things you got to look for when you're looking at this data are consistent frame times and not having dropped frames. Right, so a drop frame would show up as a missing color in your order of colors. If it's supposed to be blue, white, green, and you get blue, green, the white frame was applied to something on the overlay, but it was never actually shown to the user. That's a problem. And then consistent frame times is what allows you to get smoother animation on the screen. So if you have a bunch of 15 millisecond frame times all in a row, that's a perfectly smooth animation. You're not going to have any problems with that, more than likely. If you have a bunch of 40 millisecond frames, it's slower frame rate, but it's going to be consistent, right? And it's going to be pretty level and pretty flat. The problem happens when you start to see a 2 millisecond frame and then a 20 millisecond frame and then a 2 and then a 20 and then a 2 and then a 20 and then 2 and 20 back and forth. And when you start to see those issues, two things come up. One, the animation is not nearly as smooth as the Fraps reported frame rate would normally tell you, because Fraps only sees that 2 frames were shown in that period of time. It doesn't know that one of them was 2 milliseconds and one of them was 20. It knows that they're different, but not that drastically different. And the graph that Ken's showing up there now, it shows Crysis 3, is that orange band. So that's actually a scatter plot of all of the data we have. And the orange is it's not like a line graph filled in the bottom. That is because there are so many frames that are going from nearly 0 milliseconds up to 20 or 30 or 40 or 50, you get this massive orange color. So ideally what you want is what the green and black colored bars are there, where they're very narrow. A narrow bar indicates that the frame times are consistent, they're smooth, you're not going to get any drastic stutters, and that kind of stuff. The blue bar is the 680 SLI. You notice it's a little bit bigger than what you get with the green or the black bar, and it has some more problematic points with sharp spikes or hitches or whatever you want to call it. But the orange bar is a completely different story. It's completely...
It's like mountains in the background.
It is.
It's the Grand Tetons of GPU rendering.
So the two takeaways I have from that graph, if Ken shows that up there again, is one, the perceived frame rate is actually, if you scroll down or up, I'm sorry, Ken, to the observed frame rate versus the nope, one more. There we go. So notice that the observed frame rate here of the orange bar matches the black bar, which is a single 7970, the majority of the time. That is because those small runt frames, those small tiny frames of 2 milliseconds or 1 millisecond of time that are on the screen but represent almost no value to the animation sequence, if we take those away, what you get is this observed frame rate that is not really any better or much better than a single card. So not only are you getting potential stutter and potential animation issues, but you're not getting the value of that second card in your gaming performance. Right.
But what if you bought the card simply for power consumption and heating reasons?
Well, see, here's an interesting question for you. Is it fair to say then that you are getting input latency responsiveness benefits out of that? Would you think?
I think it might be worse.
There's also an overhead of any kind of multi-GPU that induces more latency. So.
Yeah. Might make it worse.
Yeah.
You think it might make the input latency worse? Why would that be, do you think? Just in theory. I don't know the answer to this yet, but
I don't know. I mean, you got another card, but it seems like they're fighting each other really more than anything. If all you're getting is a couple of pixel width little band on the screen, and that was your supposed additional frame, right?
Well, it's also when you compare simulation time, which is, the application you're running has the simulation time. It sends out a frame to the first card. Then it sends out a frame to the second card. And the first frame gets processed, and that one does it, but it doesn't take as long to do the second one, potentially. And so, yeah, you get that short 2 millisecond, it's render, and then it's waiting for the simulation to, still go through the overhead of figuring out which card gets what for AFR. Yeah, I think that's where that whole sawtooth pattern comes, that simulation time is really not geared towards multi-GPU as effectively as it could be.
Yeah, because in that graph, the frame times were actually exceeding that of even the single card, right? Intermittently, but it was still happening. So you had this SLI setup, and it was taking longer for some frames than and that's gonna be additional. I don't want to call it lag, but delay. I mean, it's taking that a little bit longer to get that
can
frame
we go
on the
to the,
display.
the Battlefield 3 page of that, and go ahead and scroll down to the 2560 by 1440 results, and let's start with the plot graph there, where we have the big splurge of orange. And when we get there, what you see is, again, you see the same thing. You see this almost 0 millisecond frames and then these high frames. In this case, what's interesting, because I thought of this when Alan brought that up, the black line that represents the single 7970 almost perfectly matches up with the top of the 7970 Crossfire result, indicating that it is, in fact, limiting by 1 GPU. And another, I think one of the theories that happens with this, or that we have with this, is that AMD is passing the information to these GPUs at almost the same time. And it says, okay, GPU 1, you work on this, GPU 2, you work on this. And it's passing them to them at almost the same time. It's getting the result at almost the same time. And so the second one is only a little bit behind it, and when it displays the difference, these two frames are only off by that little runt of a difference. It's only displaying that, and by that time, it's already sent off the next one to the first GPU, the next one to the second GPU, and you get the same thing back. There are some cases, Dirt 3 is one of those, where we see this pattern where it kind of goes in and out of this runt mode, I guess I'll call it, where sometimes it'll be smooth and a tight band of color, and sometimes it'll expand out. And there's more to find out about what is causing that. Is it a CPU bottleneck? Is it a GPU bottleneck? Let's go down to the next graph there, Ken, and it visualizes an individual run of the 7970 Crossfire. Oh, I'm sorry, you changed pages on me. If we go back to the Battlefield 3 at 25 by 14, 7970 Crossfire, yeah, there we go. You'll see the individual graph. Right, so if you look at that, you'll see that the black band at the top is what Fraps would see in terms of average frame rate per second. And then the bottom bar is the blue bar, which is what we report as the observed frame rate. And that is after taking away all the runts. And you'll see some drops in there in red towards the front half of the graphs as well, a little bit harder to see. If you go to the website, any of the graphs you see on this article can be clicked on and enlarged and made a little bit bigger so you can get a little bit more detail. Compare that to the graph under it of the 680 SLI, where you only get the blue bar. There are no runts, there are no drops seen. It tells a really compelling, if you're an NVIDIA fan, disappointing, if you're an AMD fan, story about SLI versus Crossfire. And I don't want to go through page after page of results, because
no, but it is worth directly pointing out with this that single GPU, much more closely matched.
That's true.
As much as we want to emphasize the Crossfire thing, and it really is worth empathizing with AMD and emphasizing to you guys. Single GPU, they're actually pretty equal. So don't see this as beating up on an AMD or beating up on an NVIDIA. Right.
No, that's a good point, because if you look at the single GPU results, they very closely match with Fraps. They very closely match with what we had expected and seen with Fraps. Whereas, like, the 7970 is a little bit faster than the GTX 680. Single card, it really is. Even on this method that NVIDIA quote helped develop, right?
And something to consider here as well is when we're talking about runt frames and drop frames, those frames are being rendered fully by the GPUs involved. So both of the cards are doing work. It's just the presentation that is flawed. Now, with NVIDIA, they have both hardware and software metering, where they can offset those frames a little bit more, so you actually kind of get more for your money and a smoother overall experience. I mean, AMD is still doing the work, but they're just not displaying it in the most optimal way for our human visual systems.
So, and it's almost like I don't understand why they wouldn't have noticed this and thought, okay, we're wasting resources, right? Like, the response I got back from AMD was, okay, if we introduce latency into this pipeline and we make them smoother, we'll be holding back the input latency will be increasing input latency on half of our frames. Their excuse, their answer is that we are displaying the frames as soon as they're done being rendered, and if you have VSync turned off, that's what we think you want.
So I have a question about this.
Sure.
As far as how Crossfire actually works. So both cards are working on their respective frames, one right after another, supposedly. And ideally, if you only had, say you had these two frames that you want to display within one of the 60 hertz refreshes of your LCD, ideally you'd want them to be like half and half, not like with a thin runt band in the middle, right?
Yeah, you don't want thin run bands because that really it kills the animation on the screen.
Right. It's sort of a non-frame, really, because it doesn't really do you much good anyway, right? Or if you were squeezing 3 frames within that one 60 hertz cycle, you would want 3 even bands, not a top half of runt and then the bottom half, right? Because it's sort of, you just lost a third of whatever the updating was, right? It just didn't appear. So what I'm wondering is, maybe this is something inherent with how AMD decided to implement Crossfire, and both cards work on their respective frames, and then that raw frame, like the actual bitmap, has to go from one card to the other to go out, right?
That's the case with both SLI and Crossfire, yeah.
Yes, I agree. But is there something up with AMD's implementation, or maybe both cards have to stop everything they're doing in order for this data to transfer over, and then they don't want to do that because that would slow down both cards a different way? Or is that what's going on here, or what's the real
difference? Is NVIDIA has implemented hardware-based frame metering. Since the G80, they've had software-based frame metering in their SLI drivers, I think. They've had software-based frame metering since SLI was reintroduced. As of G80, I think it moved into hardware, where it could be more efficient. And the idea of frame metering is that the theory is presenting a frame too late is bad to the user, which I think we've proven here, showing those run frames, they're too late, it's no point. But showing a frame too early can also be bad for the animation. So NVIDIA's frame metering technology, they haven't gone into a whole lot of detail about what actually it does, but what it attempts to do is, based on GPU workload, kind of send the signal to the graphics system of when these GPUs are ready for the next frame at different times. So it tries to space out those calls so that you get an even animation across the board. Now, it's not easy. It's a very fluid algorithm. It has to change all the time based on, if the frame rate spikes real low all of a sudden because of a big explosion on the screen or a whole lot of activity all of a sudden, it needs to be able to adapt to that quickly and ask for more frames from the game as quickly as possible, or slow things down depending on whatever the case happens to be. And AMD does not implement any kind of frame metering. It simply says, here's a frame, show it to the user. Here's a frame, show it to the user. Here's a frame, show it to the user. Whereas NVIDIA is purposefully kind of expanding and contracting this frame timing metric to meter
to the point where they're doing adaptive VSync and stuff like you found later on.
Yeah. And I think it's that technology, this metering, that allows them to do adaptive VSync, that allows them to do smooth VSync, that allows them to do a lot of that type of stuff that we haven't seen AMD implement for any particular reason, one way or the other. But I think this maybe is more indicative of why they haven't done any of that kind of stuff. I don't know. Are there any? I'm trying to remember if there were any other particular result sets that stood out. I mean, so half the games in Crossfire had this problem. Battlefield 3, Crysis 3, and Sleeping Dogs had this runt problem, this alternating, oscillating jigsaw, sawtooth pattern, whatever you want to call it.
Well, I think it was Crysis 3 that it was the drop frames, not even runting, but just straight out dropped.
Well, see, we only had big drop issues at 5760 by 1080,
True.
which is really different. That I'll touch on that separately here in a second.
Yeah, get into the multi-monitor support on a single monitor card, eh?
But so Battlefield 3, Crysis 3, and Sleeping Dogs at single monitor resolutions showed this runting problem is really, really bad. Dirt 3, Far Cry 3, and Skyrim did not, at least as much. Like if you look at Dirt 3, it didn't happen at all at 19 by 10. It happened a little bit at 25 by 14 for one particular little instance, and we saw that kind of happen on multiple runs, of course. But it presents an interesting thing. Like, so what is the difference between what Dirt 3 and Skyrim does and what Battlefield 3 and Crysis 3 does? And I don't have any proof behind this yet. It's something I'm still looking into, but I get the feeling that when the CPU is a bottleneck or a part of the bottleneck, that the Crossfire is kind of evenly pacing itself out by some kind of accident. Whereas when the GPU is the definite bottleneck of things, which I would expect to be the case in Battlefield 3, Crysis 3, and Sleeping Dogs, the GPUs show its worst case scenario. Look at Skyrim. It does scale when you increase GPU performance, but it has some CPU limitations. You look at Dirt 3 and it's the same way. It has some CPU limitations. And Far Cry 3 shouldn't have CPU limitations, but Far Cry 3 as a game engine is kind of broken. I think it has some CPU limitations because of that. If you look at our Far Cry 3 results, they don't really look good for any card, single or multi GPU, to be perfectly honest with you. So that's kind of like my running theory on what we've seen so far. We've only posted results for
Far
the
Cry
79.
2 kind of the same way, that they almost a bridge too far when it came to rendering technology? I remember having some problems with that as well.
I don't know. Yeah,
Okay.
maybe.
Move along.
So,
Yeah.
so the end result here is that for AMD to fix this, they're going to have to compete with something NVIDIA has already implemented in hardware.
Yes. And that's their answer has been, we are working on a fix for this, expect it sometime in the summer. Which would be, my assumption, is a frame metering technology of some kind. Now they could make it look better without actually improving things. They could they could just decide in some games in their driver to artificially introduce crossfire frame latency. Right? They could say, oh, if you're running Sleeping Dogs, I don't know, introduce 15 milliseconds of frame latency into every other frame, right? Just because it would even things out on our graphs. I hope they're not doing that, and we're looking at ways to kind of detect how they're doing that. And I think we can test that kind of stuff when we look at input latency. But they could fix it that way. Hopefully they're going to take a more adult approach at it, a more professional approach at it, and say, we actually want to fix this problem. We actually want to make the experience better for gamers. They've also said that they may have it be a checkbox feature. If you think that the old way gave you better user responsiveness with your mouse and keyboard, choose that option. If you like the evenness of smoother frames, choose that option. I'm for that. I think that's great. I would encourage NVIDIA to have that option as well. I think they're maybe close to making that kind of call as well. So
It seems to me that they are going to do it the right way because it's so many months out. I mean, if all you're doing is adding 15 milliseconds of latency to one of the cards, then I think that's kind of an easy driver fix that you can make universal just by kind of retarding the timing of the second card.
Yeah. Yeah, you're probably right. I really do hope so. I do hope so. We have a lot more data to present to you. This particular article showed the 7970 and the 680. I have results from basically every card in the NVIDIA stack through the 650 Ti and basically every AMD card in the stack through the 7850 and the 7790 at this point. So we're going to kind of release that on a every other day schedule, hopefully, for you guys, because I didn't want to put 48 pages of graphs in a single article. Also, I couldn't physically, mentally handle that to begin with. So keep an eye out.
You're not a novelist?
Well, I felt like it after this, but
Came close.
these successive articles will be
Were
much
you
shorter.
channeling JJ?
Yeah, no joke.
Nice.
Other things to point out, we posted some videos that kind of try to help you visualize what runts and lower frame rates actually look like. We compared, I think it was 660 Ti versus 7950 Crossfire. 660 Ti SLI versus 7950 Crossfire video examples to show you, and I think in all 6 games, except for Dirt 3, which is a single GPU, to show you, okay, here's what the difference is side by side. And we do slow it down sometimes. Skyrim in particular, I think we slowed it down to 50% and 30% in a couple different instances. But you can see that while the Fraps reported frame rates would actually show the 7950 having the better experience, if you look at the animations, it's clearly not the case. And for those of you people that don't want YouTube to introduce any more issues into it, I think we're using the mega.co.nz, so you can download the source files that we made of that. So thanks for the free
go, Mega.
Yeah.
Hey,
what else?
The next portion of this article you're doing, what are the 3 cards that you're comparing and contrasting?
The next article will be the GTX Titan, GTX 690, and the GTX 7990, aka 7970s in Crossfire.
Can you give us a little preview of what to expect from that particular number?
Well, if you looked at this, you'll see that the 7970s in Crossfire don't look real good. And the 7990...
Could you maybe... Okay, I'm sorry. Captain Obvious.
Results, right? So the 7990 is essentially 7970s in Crossfire. So it's not going to look any better than this. And the GTX
But it's on the same
690
PCB.
What?
It's on the same PCB. It's got to be better.
Yeah, sure, of course. And the GTX 690 is a dual GPU card. So you can kind of look at the 680 SLI and get an idea of what that stutter might be like. But then the Titan is interesting, and because it's a single huge GPU. So what advantages does that have? Remember when the Titan was first released, and there was a lot of fighting about, well, why would I buy the Titan when the 690 is 25% or 20% faster in some games? Well, as it turns out, sometimes that 20% faster also means 20% more frame variance, which means 20% more potential stutter. And so getting a single faster GPU may be the option to go with, but you'll have to find out sometime Friday. So that's
Friday. Find
also
out on Friday.
VSync discussion in here. There's a whole page on what it does, what it changes. It does in some cases get rid of the runt issue that AMD has, but it introduces other issues like input latency and that kind of stuff. Also higher frame variances, because jumping between 33 milliseconds, which is 30 frames per second, and 16 milliseconds, which is 60 frames per second, which is what your traditional 60 hertz monitor would do, presents a lot of uneven frame times. And that stutter that is created is actually, in my opinion, even more damning, even more noticeable than just your everyday type stutter. So if you look at that frame variance graph that Ken's showing up there, it's interesting because you can see this is a percentile graph, and we're looking at GTX 680 SLI and VSync versus standard SLI versus a single card. And the SLI VSync, the frame variance has nothing to do with your frame rate. It has nothing to do with frame times. It is simply a measure of how different is the current frame in relation to the 20 previous frames. And as you can see, there is more variance introduced earlier in terms of what percentile into the system as a whole. And as such, the stutter, the uneven animation is going to be a little bit more apparent. That's why I think if you go down to, if you go to the Crisis with the 7970 frame variance, you'll see that it actually looks better with VSync than it does without VSync because of it kind of gets rid of the runt issues. It's interesting stuff down there. And if the Battlefield 3 2560 by 1440 results kind of show you that it can actually even get rid of the runt issue altogether if you're able to maintain that 60 frames per second mark. So there's a lot more stuff to work on that, and we're going to try to measure, what your input latency, how it changes when VSync is enabled, whether or not Crossfire adds more latency than a single card does because of that as well. There's a whole lot of stuff to look at with there. Jeremy mentioned that we looked at adaptive VSync and smooth VSync on the SLI setup as well, which is kind of interesting to see how
And I
those.
bet you can't wait to bring Lucid Logic into this.
Yeah, we've had several comments by people trying to do virtual VSync and see what that does, and that's just another variable to have to add in to all that stuff as well. So that's frame rating so far.
You know, Ryan, I got to say this. I think I submitted my first article in 1996, went at it kind of full time in 1997. Seen a lot of stuff come and go. One of the first, 3D graphics enthusiasts. And out of those entire 17 years I've been doing this, this is probably one of the most impressive articles I've ever seen, period. I mean, the amount of work that you put into this, money, the accompanying videos, explanation about what it does. I thought that your graphs and the way your presentation was a lot more clear about what you're trying to do than a lot of the other guys. And again, this is probably because you've been working on this a whole lot longer. So, I really was truly, honest to goodness, impressed by what you have done. I mean, this is one of the top 5 articles I've ever read in my life. And I want to raise.
I appreciate it. I mean, it's probably one of, if not the longest articles I've ever written, just in terms of word count. I think it ended up being about 16 or 17,000 words, and I cut it back because I didn't want to cover all the. You can ask Ken. The original plan was to put every result that we had, and I'm trying to remember the math. It was if we did 5 graphs per resolution per game per comparison. I think it was it 40 or 940 graphs that were generated through these scripts, and I was like, okay, that's like 52 pages worth of benchmarks. I don't think that's navigable. Like, what's the drop-down box look like for that on the website? So I wanted to break it down, and I also didn't want to short any of the explanation of why we did certain things or why we tried to do unique things. Like, a lot of the people will, other people that have access to these tools, the FCAT tools that NVIDIA put out, you'll see Tom's Hardware and Tech Report and AnonTech, and they'll all do cool and interesting stuff with it. But because I've had the benefit of having working on this for a long time, we are able to do things like generate this idea of what a frame variance is, how maybe that affects stutter. We don't have a clear-cut definition of stutter. I think it'll end up coming down to 2 definitions of what a specific stutter is, like a big hitch versus micro stuttering, and how you measure those independently. But I think our idea of this frame variance graph kind of gives you an idea of how much potential there are for those types of things. I don't know. There's still a lot of work to do, and it's. I really do feel like it's been a focus at our office for at least a year. It's taken up dedicated space at the office for at least that long, and I'd say for probably the last 6 weeks, it's been like the everyday thing that we do every day. So I was really, really glad to kind of get this out and finally publish it and get some feedback. The more people that read it, the more response we get. I would greatly appreciate that. If anybody has comments or thoughts, you can leave them in the comments. You can email me directly. Ryan at PCPer.com works. And if you like what we did, then tell us about it. If you don't like what we did, tell us about that. If you have any suggestions or ideas, send them to us. We want to see it. So that's the goal. Is we hope that this actually changes things for the better. Like Jeremy said, that we're not trying to piss off AMD. Far from it. Like I said, AMD still showed the best single graphics card performance, even with the new system. It's the multi-GPU side that needs work, and we believe that people should get what they pay for. They should get what they're promised. And it's unfortunate timing that it happened to be the day after they announced the 7990 was coming out.
Please, Roy, may I have a better driver?
The scariest thing about this whole ordeal is Ryan and I had to write code. That's just not not pretty at all.
Coding.
I'm a political science major. Let that sink in for a little bit.
Son, going through life as a political science major.
Yeah.
Okay, I'm going to be honest with you.
But I can write
using hard
code.
reviewer as your fallback position.
I can write code.
I mean, I had to learn Perl, yeah, that's not fun.
And have an NDA branded on your head for a little while.
I had to translate somebody else's regular expressions code, which is apparently really hard. But anyway, so that's frame rating. Read the article. We'll definitely talk about it next week because we'll have had all of the results out by next week, and we'll go through maybe another kind of closing summary, and then we'll move on to the next edition of that project. Now we have a bunch of news items here that I suddenly have no interest in talking about. I'm sorry. It's late here, and I haven't eaten yet still. So let's ask. Alan, is there something in specific here that you thought was worth discussing? There's the word flash here. I don't know if that's interesting to you.
It's these guys came up with a new method of. This is one of those things that's still on paper, basically, or it might have a prototype sort of deal. But new method of making the floating gate of flash memory, like the channel that actually holds the charge. So it's a chemistry change, basically, to how flash memory would be made. And assuming that this works, then they can make the channel smaller. You can cram more onto a given space. The typical shrink sort of thing. Except this wouldn't be a nanometer shrink. This would be the channels are just physically smaller. You can just pack more in, sort of thing. That's really all there is to it.
They're atoms thick.
Yeah, it's really
Atoms.
it's
8 layers or so.
what was the compound?
Molybdenum.
Molybdenum disulfide.
Yeah.
They're using as like sort of a binder.
Sandwich between graphene.
Yeah, and then graphene for the gate. So
I've got a question. Are we ever
Yes.
actually going to see graphene used in anything?
well,
We see it used in PR all the time.
Yeah, exactly. How many years have we been hearing about graphene? I know how research works and it's all theoretical, but come on, it's kind of seems like a hoax at this point.
it's there. I just think that the methods of the methods of actually layering the stuff onto wafers is not what's there yet. So
Yeah,
let them
graphene's
figure out all
used
this
in other
theory. That's
stuff.
good. I'd rather they figure all this stuff out now, and then hopefully somebody else figures out how to make it easily producible in that form later. I'd rather it be that way, not the other way around. Like, oh, we can
Yeah,
produce
well-
it, but we don't know what to do with it, right?
They still have to get around that whole EUV thing. Everybody's invested billions in the technology, and it still doesn't work. If you read anything about EUV, about how they actually do it, it's like free fall chemistry with high
It's voodoo.
charged particle physics.
Just say
it's
it's
just
voodoo.
this shit's crazy. Read about it. Read about how they make the light source for EUV. It's PFM.
Yep.
Pure freaking magic.
Other news, let's see. Corsair did some stuff. The Xi3 piston is available for pre-order. Project Shield. AMD announced Sky graphics cards, which is, I guess, their answer to grid technology, so cloud-based gaming acceleration. They do have one advantage that I learned about today, is that they're able to stream out six individual game streams per GPU, and I think NVIDIA is limited to 4, so they may have an advantage there. But this is still a product looking for a market to sell to in the U.S. at least. It's just NVIDIA. AMD just basically says, okay, look, we want to make sure we have a product available for that market, so here it is. I don't think we have a post on it. AMD did announce the 7990 reference card, essentially, at last night's press conference, which is two 7970s running in Crossfire, two ASICs. I don't know the exact clock speeds or anything like that yet, but although it's not the first time they announced it, I guess they announced it kind of at the initial Radeon HD 7970 release too, and we saw how that turned out. But this one will probably come out, and we'll as far as I know, still get one. I don't think AMD's that is going to be cutting us off or anything, but hopefully that'll be another reason for them to really push forward and fix these drivers.
Yeah, I was going to say, what good is it if every other frame is a runt?
I actually, to be honest, I told them in my discussions like before this.
Hey! They prefer to be called little frames.
Oh,
Yeah.
I told them in discussions I've had before this announcement. I was like, if you're planning on releasing one, if I were you, I would wait until you have this driver fixed. So
those frames are vertically challenged.
Yes.
I don't get the dollars. And then let's end on
Pixel
this.
deficient.
Well, let's end on Pixel Sync. This is Intel announced Pixel Sync and Instant Access, which are two DirectX extensions. I don't know. I didn't know you could do extensions DirectX. Josh, does that just make it like special driver?
Well, DirectX is not heavily extensible, but I've heard that. Well, I mean, AMD and NVIDIA have done extensions as well to it, but it's not as obvious, especially in like OpenGL. Extensions were very common. You could still do it in DirectX, but it's a lot more clamped down. But I imagine if you're Intel, you can do pretty much anything you damn well want.
Yeah, I would have guessed that too. So I learned about these tonight. That was actually the meeting I was at right before this. Pixel Sync. Let me go with the other one first. Instant Access allows the CPU to read from GPU memory, and I guess the other way around as well. It allows the CPU to change GPU memory. So it's not a complete shared memory system. There's a little bit of limitation on it, but it allows more flexibility than they've had in before. This is only on Haswell, only on the 4th gen architecture. And then Pixel Sync is, how did they word this? It allows you to change the order in which shader operations are performed kind of on the fly so that you can have order independent effects like smoke and fog and that kind of stuff on the system. And it is done in a much more efficient way than the brute force method that order independent transparency is done today. And obviously Intel is interested in that because their GPUs aren't as powerful as what you get with discrete options. So anything that helps bring up the performance of Haswell's graphics, they want to do. They were very adamant in the meetings tonight about, here's the game developers we work with. They brought the guys who do Rome Total War up. They showed off Rome
Were
Total
all those
War.
guys beat up? Did they have like whip marks along their back?
The Grid 2 guys, Codemasters, came up, and they talked about what Intel has changed and why they're working with developers much more closely now, and talking about the fact that 59% of all the GPUs on Steam or something like that, they're the most popular single GPU on Steam by far. Maybe it's not 59%, but something like that. And they have. I mean, I think they were talking about 70-something% market share on notebooks. It's like, well, if you buy a processor, you have Intel HD graphics. That's not really a fair comparison. It's more like I'd like to know how people use one versus the other. But they're definitely the dominant player in the field, so it's good to see them changing things. Let me tell you my one worry, and I'll let you guys see if you think it's fair or not, and then we can move on to our closing thoughts for the episode. I worry that if Intel starts to spend a lot of money to get game developers on board to develop for Haswell, that we will see a decline in the desire for game developers to push for higher-end features.
I disagree.
Okay.
Because there are two other companies that were pushing very, very heavily against that. And I'm not talking NVIDIA and AMD, but Microsoft and Sony. They've both invested billions in the console market to make them look pretty, that as pretty as they can with current generation technology, that they're going to want to push away as much as possible from Intel possibly dumbing things down. Then you also have NVIDIA and AMD, providing large pieces of silicon that all they do is render graphics rather than CPU and graphics. And, guys like Crytek other independent places, the benchmark guys, they're all going to want to push the boundaries of the software to maximize the biggest, baddest hardware of the time to make their product look even better, not just to consumers, but also to the guys who are willing to license out these engines for their next generation games, whether they be on consoles or independent PC games. So I think that Intel is a big factor because they've got a lot of money, they've got a lot of market share, but there are a couple really strong external forces that would be pushing directly against that.
All right. Yeah, I mean, I hope you're right. Yeah, okay, that's good. It makes me feel a little bit better. I hope you're right because there was a couple of little side developers made today while they were presenting that made me think, oh, that doesn't make me feel warm and fuzzy inside, right? That they might think about, that they're no longer focused on targeting towards the high end. They're targeting Haswell instead because it's the largest user base. But I don't know. We'll see. We'll see how things go.
Hey, the wow factor sells. Why do you think guys remember when the PS3 was first announced? What was that game that they didn't say it was pre-rendered, but they were kind of hinting that it was a PS3 exclusive title? What Retaliation? I can't remember.
I can't remember either.
What is the one with the guys?
About.
They always have the face, the gas mask type looking.
Killzone 2.
Killzone 2. Yeah, I mean, when you first saw those the movies of that, you're thinking, "Wow, this is real time rendering. The guy's shooting stuff. It looks awesome." And then it didn't look nearly that good. But still, there was the wow factor that got people to drop their jaws, pull out wallets.
But it's still a niche market.
The PS2, PS3 is a niche market?
Well, no, but wow factor is. Console is a purchase that someone's going to hold on to for a long time.
But dude, graphics. There's a whole site that all it is using F words and talking about graphics because it's true. We've got graphics.
We've got lots and lots of graphics. But
Battlefield 4 trailer, anyone?
Exactly.
Pretty impressive. All right, let's finish this damn episode and get into hardware software picks of the week. I don't really have one. Somebody, I don't know if it was Scott or it was probably Scott, put in the Metal Gear Solid 5 trailer. That's maybe a good that would maybe be one that I think more is more in line with what Josh was talking about, which is like a trailer that never quite comes to fruition in an actual game console. But I probably won't pick that one because I never really played any of the Metal Gear Solid games.
You don't like hiding in boxes, do you?
I love hiding in boxes.
Especially not when you're a snake hiding in boxes.
My pick is just going to be the Vision DVI DL card because it is the card that has enabled me to do all of the stuff I've done this week. So that's it. That's all I got.
How much is that card worth? How much can you buy it for?
Should we pay for that? And $1,400?
Yeah, $1,400 or $1,500.
Yeah, it's $1,400 or $1,500 capture card. So
and Nvidia gave a bunch of sites each one.
Did.
Yes.
Why couldn't I still have a website?
Because it's kind of useless unless you're doing this specific thing.
Exactly.
All right, Jeremy, what do you got?
I was kind of reaching this week too, but if you've got a weak Wi-Fi signal, you're tired, bored, and lazy, there's a semi-effective little tutorial that came up on essentially how with some tin snips, a beer can, and some tape, you should be able to get a better signal if you have to deal with interference. It's not going to be as good as, even the Pringles can mod, but it has the benefit of taking zero effort, very little time, and it gives you something to do with that empty beer can. You look at it, it won't interfere with MIMO stuff. You are still better off doing a proper parabola, but hey, that takes time and energy. This is cheap and easy. Give it a shot.
Fair enough, Josh.
And yes, it is a minute.
She looks like she could do some minute hacks. Oh, dear Lord. Anyway, too bad this particular product does not have a more adjustable stand because it looks really neat. 24-inch, 23-inch IPS. Look at the size of that bezel.
They have
Bezel.
to be exaggerating. There
What
is
bezel?
no way in hell.
No, it's supposedly not
The
exaggerating.
bezel
at
itself,
all.
yes. But
No, I
displayed,
guess
I,
that's.
bet you there's still another 5-6 millimeters that aren't actually displayed.
Who the hell knows? Look at how skinny that is.
Yeah, that sort of looks
That's
like
like
it's
the
photoshopped into there.
antithesis of me.
Yeah, that is
Asus put
Photoshop.
out one. They did the same thing. So I think, was it ViewSonic? The bezel is physically that small, but there's another
idea.
good chunk of the screen that is just not displaying.
Look at
Well, you
this.
could be
Look
correct.
at this not straight line at the where the image ends.
Yeah.
Yeah.
Well,
I call Photoshop.
Well, they Photoshop all of those hero shots because no display is going to look like that when you take a picture
click
of it.
on the bottom picture because that'll give you the best one. That
Yeah.
will show you at least the amount of kind of screen space. And when it's turned on, you're not going to get a whole lot in between the edge.
That is still a pretty narrow bezel.
That's
Yeah.
very narrow.
I just want to see if it displays all the way to the edge of that or if it cuts out.
An interesting discussion.
Maybe we should review that.
somebody buy
Please send
one.
us one.
Somebody call LG. Stat.
Call them up.
Yeah.
All right, fair enough.
All right. So, all you people out there that are still using hard drives for your operating system drive, and your complaint is that 128 gig is too small for all your stuff that you want to put on there, and they're too much money, and no. Okay, so go to buy.com before the 31st. There is a Samsung 840, which is the triple level cell version. It's not the 840 Pro, but that's still plenty fine for anybody just unless you're extremely hard on your storage. 250 gig, $147. That is 58 cents a gig.
This
You
website's
haven't-
pretty terrible.
You have to, yeah. You have to add it to your cart to see it. If you're gonna have to go to the link off of the show notes because the link that I got was from the email blast that they send out to people with their stuff.
Yeah, Buy.com got bought.
Yeah, but you add it to the cart, and then when you go check out, the price is $147, and you have to actually log in
Just on
to the
that one.
website. And
I
what?
still remember my $150 check from Buy.com in the early 2000s because do you remember when they sold that 22-inch monitor or 19-inch CRT monitor for half the price of any other? And it was a mistake on the website, and thousands of people ordered it, and
Yep.
they didn't remunerate anybody. They sent out about 150 of them. People got charged, they got refund, and then somebody did a class action suit, and I got $150 out of it.
Sweet.
It's pretty good for a class
Free
action.
money from Buy.com.
That's why they got sold.
So the 840 is a little bit slower than the 840 Pro on writes specifically. When it comes to reads, the stuff you're doing most of the time, it's right at the same level as an 840 Pro. So is a good drive. Do it.
All right. Is that everybody? Did we go through 1, 2, 3? Yeah, close enough.
Ken should start
so-
giving us picks of the week.
I got nothing.
I trust me, I got nothing either. No.
Because we're
Tank is
only
on.
going an hour and a half on this now.
Well, let's end it and get the hell off of the show then. Thank you, everybody, for watching. This has been the PC Perspective Podcast. You can find us at pcper.com/podcast. And we appreciate you sharing that URL with people. If you found the frame rating discussion interesting, feel free to link to that on any and all forums that you may attend and spam it out or just politely place it. And then if you want to watch this live, we record it on Wednesdays at 10 p.m. Eastern, 7 p.m. Pacific at pcper.com/live. So with that, we will see you next week. I'm Ryan Shrout.
I'm Jeremy Hellstrom.
I'm Josh Walrath.
And I'm Alan Malentano.
Thanks, guys.